Okay, so now that we've established the pattern and we're never gonna draw all these pieces again, we're gonna think about all these other issues that come up when you look at the worksheets we're doing. It's like, why do they ask all these questions? Well, here's our standard form, and it's going to work the same for cosine, secant, cotangent, blah blah. We're going to have the same standard form, but since we're just using sine now, so we got a, b, ps for phase shift, and cl for center line. So what we're going to do is see what all those things equal. What in the stuff? All right. So here we go. The domain, you're thinking, well, domain, that's easy. We've been doing domain since we were little kids. The domain of a sine curve, you're thinking, well, I can go round and round the circle forever and ever and ever. I can go round and round forever. So you're saying this curve here, this curve could just go on forever and ever. You're right. That curve could go on forever. So that means your domain is all real numbers. So negative infinity to infinity. It could go on forever. But then, like, what the heck? Restricted domain? Well, restricted domain is just basically what we're graphing. So what we're graphing are between negative 2 pi and 2 pi, just our two periods. So the restricted domain is essentially just going to be your endpoints. Okay, and it's continuous. It's one nice curve. So your restricted domain is going to be negative 2 pi to 2 pi. It's basically just taking the endpoints that we came up with, and that's what we're graphing. That's the domain we're graphing between the two endpoints. The range, you've been doing that since you were little kids. The range is your y values. So your lowest y value is -1, your highest is +1. So it's going from -1 to 1. Okay, we're going to get to this displacement. Displacement is your vertical transformations or vertical shift. They are affected by the center line. Center line. So on this particular problem that we did here, just plain old sine x, there's nobody added out here. So in this case, the displacement is 0 because there's nobody added. It's not moved up or down. The center line is still at the x-axis, which is still y equals 0. So the center line is still y equals 0. The amplitude is the distance from the center to the maximum, or the distance from the center to the minimum. So in this case, our amplitude is 1 because the distance from the center to the max, center to the min is 1. And then somebody says, oh yeah, well, the understood number in front of sine is 1. That's our a value. So the a value is always the amplitude. There's actually something about that that's going to come up when it flips over. We're going to get to that in the next video. I just wanted to go through all this basic stuff here. But anyway, so the amplitude is the distance from the center to the max, center to the min. Okay, so the distance of the center line to the max or min. So there's your amplitude. Phase shift, that's going to be our left-right shift. Are we shifting from the left to the right? So the phase shift is your left-right shift. All right, that comes from this PS right here. So we don't have a phase shift yet. We're just dealing with plain old X. We don't have a phase shift yet. So far we have a 0 phase shift. The period is going to be affected by B, but that's the last thing we're going to do. The period's affected by B, but right now the period, we did one lap around the circle, which was 0 to 2 pi. So the period right now is 2 pi. The period is the length that it goes before it repeats. The length it travels before it starts to repeat. So basically whatever corresponds to one lap around the circle. So from the starting point to where it starts to repeat, that's one period. We're going to talk about that a lot. That's going to be a big deal as we go through this. So these are the pieces that we're going to have to be answering questions about a lot once we get going on this. So we good?